Welcome to liveAIwire.com, where we take a calm and practical look at the developments shaping modern AI. In this episode, we explore 3 stories that illustrate how deeply these systems are entering everyday life. You can access every episode early on Patreon, and your support, even at the price of a coffee, really helps keep the podcast running. Let's get underway.
So the big question we're really starting with is this. Are these artificial intelligence models actually reasoning, or are they just predicting patterns based on, well, statistics?
That's the fundamental question, isn't it? Whether they truly comprehend or if they're just masters of statistical prediction.
And that distinction, reasoning versus just predicting, it feels like everything hinges on that.
It does. Because if they're just advanced autocomplete systems, that really limits their use in critical roles.
But if they can actually reason, then the potential is, enormous. The issue, as researchers at MIT have been pointing out, is that their performance can look so dazzling that it hides a real lack of contextual understanding.
It's the classic difference between memorizing the answers and actually understanding the subject. And that's exactly why those MIT researchers are so focused on developing new ways of testing them.
They want a definitive way to tell the difference.
Yes, to distinguish genuine comprehension from our very clever mimicry.
So they're not really interested in whether the models can just recite facts they've learned.
Not at all. They're focusing on tasks where models often stumble, specifically classification tasks. When a model gets it wrong, but with high confidence, that's very revealing.
It's like a spotlight on the fact that its knowledge is really just guesswork at that point.
Exactly. And what's fascinating is how they're trying to make reasoning a trainable quality. There's one project exploring something called test time training.
Wait, test time training? You mean fine-tuning a model on the fly right in the middle of a task?
Precisely. With just a handful of domain-specific examples, right as it's about to perform a complex task.
But if you can do that, and its reasoning improves, doesn't that suggest the capacity was sort of there all along, just waiting for a little nudge?
It certainly suggests the raw computational ability is there. But there's a huge caveat to this, which came out of a broader MIT-Harvard study.
Okay.
They found that while a model can be excellent in its trained domain, say, medical diagnostics, its performance just collapses when you ask it to transfer that same reasoning to a different context.
So applying that medical logic to, a social science problem.
Exactly. The intelligence is deeply contextual. It can't generalize the core reasoning skill.
Which is a fundamental limit, isn't it? It means it can't be a true general intelligence partner.
It really confirms the growing consensus that our benchmarks have to test for generalization, not just memorization. Otherwise, you've just built a very expert memorizer, not a versatile thinker.
And this issue of being very confident, but also very wrong, that goes right to the heart of user trust. That's the hallucination problem.
It is. And that's why the evaluation landscape is finally maturing. We now have formal measurements for these failures.
You mean things like the hallucinations leaderboard?
Yes. It doesn't just count errors. It specifically formalizes and measures confident but incorrect outputs.
Because an AI that says, I don't know, is much safer than one that's confidently wrong.
Much safer. And to that end, there's now a catalog of over 100 different data sets just for common sense reasoning benchmarks. It's all about making this evaluation more rigorous.
So the takeaway from the research lab is clear. Without smarter tests focused on generalization, we risk building very polished predictors that don't actually understand anything. Now, let's take this need for reliable AI out of the lab and put it right into our daily work. This brings us to the new Google Gemini feature, which is quietly putting an AI voice right inside Google Docs.
This is a perfect example of what people are calling ambient AI. It's not a separate chatbot. It's an integrated audio feature powered by Gemini that reads your documents aloud.
And it's not for everyone, is it? It's aimed squarely at the premium professional market.
That's right. It's limited to English for now, and it's only for subscribers on the Gemini Business and Enterprise tiers. It's a tool meant to give them an edge against competitors.
The integration sounds very clean.
It is. You can activate it through the Tools menu or just with the playback button right in the document.
And I like the idea of the floating controller. It means you can have it playing in the background, almost like an audiobook app.
Yes, you can pause, skip, change the speed, all without keeping the tab open in front of you.
Which is convenient, of course, but the biggest impact here feels like it's on accessibility, doesn't it?
Absolutely. For users with visual impairments, dyslexia, or even just concentration challenges, this is huge. It's moving AI beyond content creation and into, well, into bridging real cognitive barriers.
And they've put some effort into making the experience pleasant with different voice options.
They have, yes. You can choose a formal narrator voice, or a more pedagogical educator, or even a casual conversational tone.
So you can match the voice to the document.
You can. And you can adjust the speed for deep comprehension or for just quickly scanning something.
This all feels like Google racing to prove Gemini's utility. They're trying to keep up with Microsoft Copilot and Adobe Firefly.
It's very much a productivity battlefield right now, focused on who has the most useful ambient intelligence.
But this rush always creates friction points. You mentioned it's English only, for a start.
Which is an immediate limitation for a global user base. But the deeper friction is, as always, privacy.
What happens to the data? Are your listening habits, the documents you access? Is all of that feeding back into Google's main training systems?
That's the persistent question, isn't it? Users get the utility, but they often lack the transparency about how their interactions fuel the larger AI infrastructure.
And that idea, the massive unseen infrastructure powering these simple features, is the perfect bridge to our final topic. We're shifting from the local utility of an AI voice to the global physical cost of running these systems.
It's a genuine paradox. On one hand, AI is seen as this essential tool for environmental management.
Optimizing smart grids, precision agriculture, that sort of thing.
Exactly. But deploying those smarter systems can often create a larger environmental footprint than the problems they're meant to solve.
So the greener solution actually makes us more energy intensive. That seems backwards.
It does, but the complexity drives the cost. The sophisticated models require huge amounts of computing power, massive server farms, and all the cooling infrastructure that goes with them.
And this isn't a minor cost. The World Economic Forum report suggests that while AI could unlock billions in value, it also triggers these enormous new risks around energy and material use.
We're talking about vast volumes of electricity just for the computation, vast volumes of water for cooling the processors, and of course the rare materials needed for the hardware itself.
Which all have their own manufacturing and disposal costs.
Precisely. You can no longer look at AI as just a digital tool. You have to audit its full life cycle cost, which is deeply physical.
And beyond energy and water, there are other impacts, aren't there? On land use, for example.
Yes, AI-enabled systems could intensify land use or shift resource demands in ways we're not prepared for. It's an ecological problem, not just an efficiency one.
So our governance and policy frameworks need to catch up, and fast.
They do. The sources outline 3 critical paths forward to try and align AI with planetary limits.
Okay, let's break those down. What's the first one?
The first is carbon-aware AI design. This means judging models not just on their speed or accuracy, but on their energy use per task.
And making sure they don't scale their carbon footprint as they scale their usage.
Exactly. The second path is regenerative digital infrastructure. This is about a commitment to using renewables, reusing chips, and building a circular economy for hardware.
Moving beyond just efficiency to genuine sustainability.
Right. And the final path is probably the most hopeful. It's called environment-centric deployment.
Which means building AI systems specifically for environmental monitoring and restoration.
Yes, but, and this is the crucial part, designing them from the ground up to be low energy and ensuring they're deployed equitably, especially in the developing nations that face the greatest climate risks.
If we only treat AI as a productivity lever, we just risk repeating the same mistakes of older industrial systems, only much, much faster. So whether we're challenging an AI's ability to genuinely reason in a simulated environment, integrating its synthesized voice to read a daily work document, or counting the enormous material cost required to cool the underlying server infrastructure, the future of artificial intelligence hinges entirely on accountability, better metrics, and a full audit of its physical price tag.
Thanks for listening to liveIWire.com. You can explore every story in full on the website, and early access is always available on Patreon for those who choose to support us. If you work in media and would like to feature any of our coverage, we're always looking to expand our distribution, and you can reach us directly through the site. The links to the 3 stories featured today are included in the episode details below, along with all relevant tags. Until next time.